We are recording. Okay, so here we do have two lessons. We have two lessons because the first part is just things you've already done. We've already learned how to graph using this, and I want you to tell me what are some important pieces of information here. Who has one part? Who has one part? Yes, Rachel. M is the slope. Perfect. M is the slope. Jordan.
B is the y-intercept.
B, y-intercept. So when we were graphing using this method, we would put our point on the y-intercept, the horizontal one, vertical one, right? And then we'd use our slope. So for here, here's my y-intercept. It's a slope of 1 over 1, so I go up 1 over 1, up 1 over 1. You don't have to make more than one step because they're all the same step. All right, everybody feel pretty good about that? Right? We've done that. We've done a few Desmos activities. So that's why I'm able to do two lessons here, because we have that down, I hope, and today we'll reinforce. Today all we need to do different is to graph with the intercepts, okay? So if here's my graph right here, would you agree that if I find the y-intercept, and then I work and find the x-intercept, can I make my line? Yeah. So that's not very good. So we know that if we find those two intercepts, we make our line. And we can use a very simple method for this. We can plug in x is equal to 0 to find our y-intercept. Because think about that. Our y-intercept is, remember our elevators, this is like the 5th elevator, 4th, 3rd, 2nd, 1st. At the 0 elevator, when x is 0, what am I on? I'm on my y-axis. So when x is equal to 0, you're on your y-axis. That's why we plug in x equal to 0 to find our y-intercept. Guess how we find our x-intercept? Plug in y is equal to 0. You find your x-intercept. Okay. So they're going to be pretty quick, actually. Once you find those, place the intercepts on the graph to form your line. Okay. Now, sometimes folks get a little confused when they're like, well, which one is it again? Do I plug in the 0 for x to find the y-intercept, or the 0? You can see how that's where like the confusion could happen, right? Okay. What I'm going to say to you is, when you plug in 0 for one of them, you find the other one, and you can just decide I'm not even gonna think about what I'm looking for. I can just plug in 0 for one of my variables, work it out, and it'll become apparent what you're finding when you do that. Okay. So I'm going to do that right here. I'm just going to plug in 0 for x. I happen to forget. I don't remember exactly what I'm looking for. I didn't have my notes. But if you plug in 0 for x, let's see what we get. 2 times 0?
0.
4 plus y. Let's solve. What should we do to solve for y? It's 4 plus y. Let's get rid of that 4. Minus 4, minus 4. Y is equal to -4. Okay? So I know that when I plug in 0 for x, I get -4 for y. So this one is our y-intercept. Okay, so just plug in 0 for one of the variables, you get the intercept of the other variable. Let's see, so we have 1, 2, 3, 4, and this is my y-intercept. Okay, I want you to find the other intercept following the same kind of process. Find the other intercept. So I plugged in 0 for x first, and now what should I plug in? That's a good idea. Let's do that. Yeah, do the 0 for y. That should get your x-intercept. If you're plugging in 0 for one variable, you're finding the intercept for the other variable. You guys did that? Two x is equal to 4. X is? Wait, question first? X is 2. All right. And this is the x-intercept because it's at the point 2 and 0 for y. You plug in 0 for y, you find your x-intercept. Plug in 0 for x, you find your y-intercept. So Now I just have to go up here. I know my x-intercept is at 2. You see my 2 points there? What can we do with those 2 points? Graph them. Connect them with a line, and that's how we use intercepts to graph. Okay. Thumbs up, sideways, down for that process. You know, if you have them in this form where it's not in our slope intercept form, then in this form it's actually easier to find it with the intercepts. You just plug in 0 for one, you get the other, and vice versa. Okay. Let's do this one. I want you to find this all the way out. I want you to graph it and show your neighbor. I'll give you like 2 minutes for this. So we're going to graph it right here. I want you to do the 2 process, the y-intercept and the x-intercept. Graph them, plot them, and then graph them. Have you guys ever seen one of these?
Yeah.
I really love them. I mean, I don't think anyone knows about them yet. You seen them before? Why are you laughing, man? Just kidding.
Oh, thank goodness.
That's what I was just kidding. It's cute, huh? Nice. Is that new? Is or we're giving this one? Oh, really? All right, let's see. Who feels pretty confident they could tell me how to do this? You get to tell your teacher what to do. Yes. Yeah. Magnolia. 0 for x. Okay, 5. Y minus 5 times 0. What's going to happen to this?
It's going to be just minus 0.
Right.
And so minus y.
5 is 1. That's our y-intercept because it's at 0, 5. 0 for x, when we plug that in, we get 5 for y. So I'm going to go with 1, 2, 3, 4, 5. There's our 1. Yeah? All right. Excellent. Do you want to pass it on to someone else? Who do you want to pass it to? Look over there.
Yeah. Basically, so you plug in 0 for, which one did we just do?
We did where we plugged in for x.
Okay, yeah, you plug in the y,
Perfect.
and then you get like 5 equals 0 minus 5x, and then you divide negative 5.
Good. Get rid of all of it.
Yes. And then you get x equals negative 1.
Good. And that's the x-intercept because we're solving it with the intercept. We know that's negative 1, 0. So this is perfect. Here we have it. Go ahead and graph it. Well done. All right. Thumbs sideways. Oh, thumbs up, sideways down for this. Feeling it? Okay. Perfect. That's who we like to see. Thumbs up all around mostly. All right. This next part, we're going to just do this. Which doesn't belong in y? Which doesn't belong in y? Here are the things that you could bring up. If we're comparing components from a graph, you could talk about your y-intercepts being different, your x-intercepts being different or the same. You could talk about the average rate of change, which is our slope. It's just how steep it is. This has a greater slope than this incline. Greater slope means it's harder to climb or harder to climb down. right? And then you could say if it's increasing or decreasing. These are just some words that if you have word problems, you may see these words for average rate of change. But increasing, decreasing, and these are starburst worthy questions. So let's see. For this first one on the left here, who can tell me one that is different from the others and why? How do we compare it? Jackie, what do you think?
The last one.
Which one's last? Bottom right? Bottom.
Right.
There we go. And what would you say about that?
It's parallel to the. Oh, it doesn't go through the x.
It doesn't have an x-intercept. It's the only one without an x-intercept. There's another one. She almost said it. On that one, if you kind of like, well, what about that? Yeah, there's one other thing you can add to it. Katie?
You mean another square?
No. There's something else we could say about this square. That could be another identifier. But what do you think? Which square are you looking at? Which one looks different?
Say maybe the bottom left,
Bottom left. Why?
because it only has 1 point and they have a slope. If you're doing the way that we did it just now,
Yeah.
you have to have 2 points,
Okay.
right?
What is the x-intercept here? At x is equal to? How about the y-intercept at y is equal to? So you could say the intercepts have the same point.
Yeah.
That's perfect.
Yeah.
So eloquent. We pieced it out, Evelyn.
The top right.
Why?
Because the slope is positive.
If I'm going from left to right, I always read left to right. Am I walking uphill or downhill? Downhill, right?
So it's negative?
It's negative slope.
Yeah.
Here, left to right, it is a positive slope. Left to right, positive slope. What's the slope for this one?
I don't know.
Positive means uphill. Negative would mean
So
downhill.
it's like it's just chilling.
It's chilling. The slope is chilling.
It's chilling.
How about it's zero slope?
Zero slope.
Slope of zero is a flat line. It's easier to ride a bike on slope of zero. I like that. All right, how about this? I'll take 2 for the top one, 2 for the bottom one. Who has 1 for the top? What's another way we can compare these? What's another way? Nah. Jude.
Bottom right of the top one, it's the only one not pointing to the top left.
Well, let's describe the slope. How would you
Okay,
describe
it's
this?
a positive slope.
Positive slope, but I like how roundabout you said that. That was clever. Trying to catch me. How dare you? Anyone else? Yeah?
The top left.
Left. This guy.
No, the other one.
Top right.
Right. It's a negative slope. It's going down.
That is a negative slope. Is it steeper than this? No. You could say it has a negative slope, but the slope is less steep than our other negative. I like it. I like it. All right, I'll just take 1 for the bottom. 1 for the bottom one, so we can keep on going. Nathan?
The bottom left, like it doesn't have like a y-intercept.
No y-intercept. Perfect. What else can we say about the bottom left? Right here. Anyone else have the last thing to say about this? What is the slope of this? What's the rise? The rise kind of just keeps going forever. What's the run?
0.
0. So who can put that together and answer? What is the slope of this?
0 slope.
Undefined.
Why?
Because you can't divide a number by 0.
You can't divide a number by 0. The slope is what? It's a fraction, the rise over the run. The rise over the run. Up and down, over side to side movement. So what's the rise? The rise is up forever. What's the run from side to side? 0. Can you, is it nice if I say, would you like 1 out of 0 cookies? That's not even funny. It's not nice and it's not even funny. Can't do that more than once ever. If anybody sees it, you can't do it more than once.
It's like 1 out of 0 cookies.
See, that's the end of that joke. You can never say it again in your life.
It's like 1 out of my 0 square.
Good answer. All right. I have 236 subscribers. How many more do I need?
24.
14.
Almost. Less. 14. See what you did. No problem. We got to recruit our little brothers and sisters who are in 3rd grade to subscribe, because I got to make that 250. It's been like 2 months. I've been tired of saying, I ate the Kit Kat. I got to go get another. So I need you guys to help me. All right? That's right. Everyone salute. What should we say? What should we say? Subscribe or else?
Subscribe or you won't.
Subscribe or no Kit Kat?
Credit.
For extra credit. And then we can yell, just kidding? That's perfect.
Yeah, but now they know the plan.
You didn't hear that. All right. Subscribe on 3 for extra credit. ... Just kidding. On 3. 1, 2, 3.
Subscribe for extra credit.
Just kidding.
That was the best. ...